Hello students, I Jitendra Verma, Assistant Professor, Department of Mechanical Engineering, Bundelkhand University, Jhansi. I am here to teach you today from the subject engineering mechanics. Basically it runs in all the branches of BTech first year, either in first sem or in the second semester. So, from the subject engineering mechanics, today we will discuss the topic named truss, and truss actually it is a very broad topic. We will cover some few concepts of the truss. So, basically I will give you a brief description whichever we will cover in this lecture. So, in the truss basically we will cover that what is the truss, then types of the truss, and then we go for the analysis of the truss and basic application of the truss. These all four topics we will cover today. So, let us start with the topic. So, here in the truss, basically truss is known as a structure. Why it is called as a structure? Why? Because the degree of freedom of the truss is 0. Now, the truss is having certain number of members, and these members are connected to each other with the help of pin jointed, either hinge supported, or they may be welded with each other at the end of the joint. So, where they are pin supported, that point is known as joints. So, the basic component of the truss is number of members and the number of joints here. So, this is the basic definition of the truss. Now, the types of the truss. Basically, trusses are of two types. Either it is a perfect truss or it is a imperfect truss. So, here is a formula to identify whether the truss is a perfect or imperfect. So, here the formula for identifying the truss is m equals to 2j minus 3, where m stands for number of member and j stands for number of joints. See, each and every truss having certain number of members and certain number of joints. So, with the help of identifying the number of members and number of joint, we can clearly identify that whether the truss is a perfect or imperfect. So, if this equation, if truss satisfy this equation, then those trusses are known as perfect truss, and those trusses, those truss which does not follow m not equals to 2j minus 3, then known as imperfect. So, it is very easy to identify. So, let us take an example here. If suppose this is a truss which are having number of members. So, how we will identify the members? So, this is the member number 1, this number 2, this is the number of 2 members, and it is the third member of the truss, and the by combination of these 3 members it is making a structure, and that whole structure is known as a truss. Here this is supported by there is a 2 support at this end and this end, at end A and at end B. So, ABC is this whole system is known as a truss. Now, how to identify the joints where the 2 trusses are the ends of the 2 members in the truss are joint, then those joints are known as number of joints. So, here how many joints are there? 1, 2 and 3. So, there are number of 3 joints are available and number of 3 members are available. So, here if we see the value of m is how much? Here the value of m is 3, and what is the value of j? From this example if we take. So, here also 1, 2 and 3 joints are there. So, it will become 3. Now, see m equals to 2j minus 3 if we take this equation. So, at LHS it is 3 and RHS, if we put these value in this equation, it will become 2 into 3 minus 3 and it is equals to 3. So, LHS is equals to RHS. So, that we can say that this is a perfect truss. If any truss does not follow this equation m equals to 2j minus 3, then that truss is known as imperfect truss. Now, imperfect truss, now imperfect truss is further divided into two types. Those are known as deficient or redundant. So, deficient truss. So, imperfect we know that it does not follow equation m equals to 2j, m is not equals to 2j minus 3. So, two condition may happen over there. If m is smaller than 2j minus 3, then the truss is known as deficient truss, and if the m is greater than 2j minus 3, then that kind of truss is known as redundant truss, is it? So, now we will come to the next point, that is analysis of the truss. So, before going to the analysis of the truss, I must to give you certain example where the trusses are used. So, practically all of you have seen the railway bridges, old Howrah railway bridge. If we see that there is a number of metal members are there, and by adding those members we have made a big structure, and that is used as a road, as a maybe it is used as a path, or such as take an example of Eiffel Tower, it is situated in the Paris. So, that is also the example of the truss, is it? Now, we will cover the various forces are acting on the member of the truss. So, various members are analysis of the truss is very important in respect of the engineering mechanics subject. Why? Because we need to analyze the forces acting on the each and every members. On the basis of that, we can design the truss, or for particular system we can design the truss. So, we need to analyze the how much forces are acting on the members. So, that for that analysis we are having two methods. So, analysis of the truss, analytical methods for analysis of truss are: number 1, method of joint. This is a method of joint. Another method for analysis of the truss is method of section. Now, I will take an example, and with the use of that example we will solve that example by method of joint and then for method of section. So, with the help of these two method we can analyze the truss. So, let us see one example. So, here if suppose this is a truss, here it is a support, and another end at and C, suppose B and A. A, B, C is a truss. At end B and C there is a support given to you, and here one external load is applied, that is 10 kilonewton, suppose that, and the length of the member B C is given to you, that is 5 meter, is it? And the angle is also given to you here, it is 60 degree and 30 degree. Now, here we are going to use the method of joint. In method of joint, so first of all you have to consider, or you have to find out the supports which are at end B and C. So, for finding out the support, we will apply condition of equilibrium. That says that algebraic sum of the horizontal forces, it should be equals to 0. So, actually there are no horizontal forces are acting. So, no need to apply this condition. Again the second condition, that is algebraic sum of the vertical forces, should be equals to 0 under equilibrium condition. So, apply this condition. So, we know that here two forces at B and C end, there are a support. So, R, suppose I am taking this R B, this is acting upward direction. So, we consider positive, and here also at end C there is a force acting upward direction. So, we are considering it also as positive. Again at point A there is a external load applied, and that is, and the direction of this force is towards downward direction. So, according to sign convention we are considering upward forces are as a positive and we are considering downward forces as a negative. So, this will become minus 10 and it should be equals to 0, because there is no other forces are acting on this truss. So, let us according to this equation, R B plus R C is equals to 10. Consider equation number 1. Now, we apply third condition of equilibrium, that algebraic sum of the moment about any point of the space or within the truss, it should be equals to 0. So, for finding out the supports at support reaction at point B, we need to calculate the moment about point C. So, we are here to consider the moment about point C for all these forces. So, let us take here it is R B, here it is R C. R B give a moment about point C, that is R B into the perpendicular distance from the point C. So, the perpendicular distance for this reaction from the C point is how much? It is 5. So, R B into 5. Now, one more thing you have to consider, that the whether this moment is a clockwise or an anti-clockwise effect on the truss. So, the force R B is giving a clockwise effect at the point C. So, that is why according to sign convention we consider clockwise moment as a positive. So, here I am considering it as a positive. Now, the another force is acting at point A and this will give a moment about point C, and this is a anti-clockwise moment. This will become anti-clockwise moment. Now, so how to calculate it is minus 10 into the perpendicular distance. Now, suppose this new point we draw a perpendicular from point A on B C. So, it will make a new point D. Now, we need this distance for finding out the moment actually. So, for finding out the moment we need this distance D C, and D C is how much? We know this B C. So, either you can find out also the A C. How? So, suppose in triangle A B C, this is a right angle triangle. So, A C is equals to how much? If suppose this is a 30-degree angle and this distance you know, then you apply cos 30 is equals to A C upon B C, and by this you can find out A C is equals to B C cos 30. So, B C is how much? B C is 5. So, it is 5 cos 30. Is it? How much? It is in meter. So, put it meter. The unit of the AC length is in meter. So, now you have find it out the AC. Now, again this is a triangle A C D. It is also a right angle triangle. So, if you know the value of AC, then again you can find out, apply cos 30 in the triangle, it will become C D upon A C, and C D is equals to A C cos 30, and A C is how much? A C is already we have calculated over here 5 cos 30. So, put down 5 cos 30 into cos 30, is it? So, put down the value of cos 30. So, the value of cos 30 is root 3 by 2, 5 into root 3 by 2 into root 3 by 2. So, 5 into 3 divided by 4, 15 by 4, it will become 3.75 meter, is it? So, in this way you will find out the value of CD, that is coming over here 3.75. Put down this value over here 3.75. So, for this force 10 kilonewton, it will give moment about point C. So, the perpendicular distance is 3.75. So, multiply force with the perpendicular distance, it will give you the moment, and the effect of this moment at point C is anti-clockwise. So, that is why we are considering negative sign over here. Now, put down it is equals to 0. Why? Because of the condition of equilibrium. Then find out the value of RB. Now, RB is equals to how much? It will become 37.5 divided by 5. So, RB is equals to 7.5 meter. Is it? Now, it is RB is equals to 7.5 meter. Put this value into equation number 1. So, you can easily find out RC is equals to 10 minus RB, and 10 minus 7.5 become 2.5 meter. So, in this way we can find out RB and RC. As we have find it out the value of RB and RC. So, see over here BCA, here it is RB and this is RC. RB is 7.5 meter, RC equals to 2.5. Sorry, it is not in meter. The unit of the force is Newton. If here C, it is given over here 10 kilonewton. So, the value of this reaction is also is in kilonewton. Is it? Now, it is also in kilonewton, it is also in kilonewton. Now, we have to find out the forces on the each and every member of this truss. So, here how many members are there? First member, second member and third member. There are 3 members are there. So, for by applying the method of joint, we will find out the method of we will find out the forces acting on the each and every member of this truss. So, let us see, let consider joint B first. So, here is also certain points should be noted. You have to consider those joints first which are having not more than 3 unknown forces. So, for analysis of the truss by method of joint, at this point birth we noted that you have to consider first those joints which are not having more than 2 unknown forces on the member. So, here at point B 2 unknown forces are acting. We do not know the force on member 1 and we do not know the force acting on the member of 3, that we have to find out by using this method. But we know the value of RB, that is 7.5. So, at this joint we have 2 unknown member. So, we either you can consider the joint B or either you can consider the joint C, because at C also there are 2 members which on which we do not know the forces. Also you can consider the joint A, because here is also 2 unknown forces are acting, but initially with the help of known forces we have to identify the unknown forces on the member. So, initially we are considering the joint B. So, by considering this joint B, initially we will assume that some stresses are acting on this member AB like this, and like this on this member. Initially we have assumed any direction you can assume, either just opposite of this also you can assume. Now, after calculating, if the value, your value comes, if whatever the value comes, if it is positive, then the direction which you have assumed, that is the correct, and if the value comes negative, then your assumptions were wrong, and the direction of actual direction of the forces or stresses is just opposite of that. So, now see, let us consider the joint B. Here like this type of forces are acting, and this is joint B, and this is the angle, here it is 60 degree. So, we have to resolve this in x and y horizontal and vertical direction. So, if suppose this is F1 and this is F3. So, component of these F1 forces is given F1 sin 60 and F1 cos 60, here it is F3. So, by considering the horizontal force, horizontal forces को consider if we consider the horizontal forces. So, F3 minus F3 and minus F1 cos 60 is equals to 0. So, from this you can say that F3 is equals to minus F1 cos 60. Consider equation number 2. Again here vertical forces, if we see the vertical forces. So, here it is RB, RB is acting upward direction. So, we consider it positive, and minus F1 sin 60, this component is acting downward direction. So, we consider it as negative and it is equals to 0. So, from this F1 is equals to RB upon sin 60, and RB is how much? RB is 7.5. See over here, RB is how much? It is 5 root 3 by 2 into 5 root into root 3 by 2. So, after calculating it, it becomes 7.5. So, RB 7.5 divided by sin 60. Put down the value of sin 60, it will become 7.5 divided by root 3 into 2. So, 15 by root 3. Is it? So, 5 root 3, you can say that F1 is 5 root 3 kilonewton. So, in this way we have calculated F1, and from equation number 2 F1 here. So, put down this value in equation number 2, you can also find out the value F3. So, put down this value, so minus 5 into root 3 into cos 60. Cos 60 is having value 1 by 2. So, it will become 5 root 3 by 2 kilonewton. Now, see, this is negative value and this is positive value. This positive value means that whatever the direction we have assumed for force 1, that is the correct, and here for F3 the value of the force is around minus 5 root 3 by 2, and this value is negative. That says that what we initially we have assumed that it is making compression on the joint B, but it is not under compression. This is what? This is under tensile. So, the correct direction of the force 3 is what? On the member 3 is what? It is tensile in nature. So, put down the nature of this force on the member 3rd, it is tensile, under tensile, and the member F1 it is under compression. So, today we will cover this much only. We will take next lecture and then we will I will teach you about rest of the second method, that is method of section. Thank you very much.